Good afternoon and welcome to my YouTube channel. We just want to look at this question from Earth Geometry, that is ECZ past paper 2018 GCE. So this was question 7A. Without wasting time, the question reads: in the diagram below, A and B are points on latitude 60 degrees north, while C and D are points on latitude 60 degrees south. Take pi equals 3.142 and R equals 3,437 nautical miles. So this is the diagram that we have. Then the question says, calculate the distance BC along longitude 60 degrees east in nautical miles. So longitude 60 degrees east is this one. We want to calculate the distance BC, so from B to C. Now, to calculate that one, that is A1, BC will simply be calculated using this formula, theta over 360 times 2 pi r. So for the radius of the earth, we use capital letter R. Now we need to know what theta is. Theta basically is simply the difference in the latitude. So there's this latitude where B is, and then there's this other latitude where C is. So the difference in latitudes, because these are in different hemispheres, we are going to add. And so our theta, let me write it here, our theta will simply be equal to 60 degrees plus 60 degrees, giving us 120 rather. So we have 120 degrees. Then we just fit in the formula, meaning at BC is simply 120 over 360 times 2 times our pi. We are told we use 3.142, so 3.142, and then the radius is in nautical miles, so 3457. So we just simplify this one. Now 120 to 360, that's about 3 times. So we just have to do the computation there. And if we multiply, it's giving something like, let's see, let me just get a calculator. Okay, so if we multiply, we are getting something like 7,199.3693. So BC is basically, if I round it off to 3 significant figures, we get a 1, we give it to this 9, it becomes 10. So we are roughly going to have 7,200 nautical miles. So this is our answer. So we remain with a 0, we convert this one to a 0, this one becomes 10, we write 0, we transfer a 1 to the next, that's why it's like that. But of course there is another option on 2 conditions. Number 1, if you are calculating distance along a great circle, at the same time, if you are calculating in nautical miles, there is another formula that we can use. So the simple formula, that's where we just say 1 degree is equivalent to 60 nautical miles. And then that difference where B and C are, it's 120 degrees. So we are simply going to say, therefore 120 degrees is equal to, we can put X, or let me just put BC because that's what we want to calculate. So you just cross multiply there. BC is simply 120 times 60, and you realize that BC is just equal to 7,200 nautical miles. So this one is simple, but you have to know those 2 conditions for you to use this method. So we can keep these answers, and then we look at the next part. The next part says, a ship sails from C to D in 12 hours. Find its speed in nautical miles. So there is a ship moving from or sailing from C to point D, and it takes 12 hours. So first of all, we have to know the formula. So this is part A1, and then you have A2, a ship moving from C to D. So the formula is the same one. We'll talk about arc CD theta over 360 times 2 pi r. Now, the r we are using is a small letter r. Why? Because we are using this circle. This circle is a small circle, it's a latitude, and it will be denoted by a small letter. A capital letter is only used when we are using the radius of the earth. Now, we also know that r is simply equal to capital R cos x. This is the formula that gives us the radius of the latitude. So I can combine, let me just say arc CD equals theta over 360 times 2 pi r cos x, like that. So we also need to find the difference in longitudes, which is theta, or we can use any other letter for that difference. But in this case, we are saying theta is equal to. So from here to there, in terms of angular difference, that is 60 degrees east, then 60 degrees west. So we add, since they are also in different hemispheres. So we'll talk about 60 plus 60. Of course, this gives us 120 still. And so we'll say arc CD is equal to 120 over 360. We just feed into this formula, times 2 times 3.142 times 3437 cos x is the latitude. So the latitude on which the 2 points are sitting, that's latitude 60 degrees south. So we just put 60 degrees. And then we think the same thing, there are 1, there are 3. Then we can multiply as well as divide, and if we do that computation, this one is giving us something. If you check up to here, this is what we calculated earlier on. So I can even say this is about 7,199, then 3693, and then cos 60. Since it's the same, then if you do that one, it's coming to 3,599.6847. So to 3 significant figures, we round it off. This becomes a 10, so 0, 0, and then a 6. This is roughly 3,600 nautical miles. Now, with this distance, we know that speed is given by distance over time. And then the distance is this one we've calculated, 3,600. Then the time, the question says 12 hours. 12 hours. So we divide by 12. That simply means the speed is equal to 12 into 36 is 3. And then the 2 zeros, these are knots. So a knot is simply a special unit that is used, that is nautical miles per hour. Remember to subscribe to my channel and then ring that bell so that every time I post new content, you are notified. Thank you for watching.